Okay, the last of our special products is cubing a binomial. Later on, either when I come back or then later on in the year, we'll talk about how we can do binomials to the fourth and fifth power fairly easily. But we are going to talk about cubing a binomial. So again, there are a couple of patterns that we follow with this. These will be probably the harder ones for you to remember. So we have a cubed plus 3a squared b plus 3ab squared plus b cubed. And the thing I want you to notice about this pattern is that for each term, the power of a goes down, right? This is a cubed, a squared, a to the first, a to the 0, there is no a. And the powers of b go up. So we have b to the 0, b to the first, b to the second, and then b to the third. The hard thing will be remembering probably these coefficients of 3. Okay. Next, we have also a minus b cubed, which is very similar, except for when I have, because b here is technically negative, anytime I have an odd power of b, the term is going to be negative. But if I square b, obviously it makes it positive, and then this b cubed would be negative. Okay, so let's walk through just a couple of examples here. Pretty straightforward ones, but make sure that we're clear. So let's start with x plus 4 cubed. On these, I might consider writing a couple of steps. It's up to you, but it'll still be faster than writing out a plus b, a plus b, a plus b, and then multiplying all of those out. So here, instead of a and b, I have x and 4. So I want the first thing cubed, so that's going to be x cubed. That's going to be the easy part. Next, we have 3 times the first thing squared, so in our case, x squared, times b. In our case, that's a 4. Then we have plus 3 times a, which in our case is x, times b squared, or in our case 4 squared, plus 4 cubed. That's our b cubed. Okay. So we end up with x cubed. 3x squared times 4 is 12x squared. Okay. 4 squared, right, is 16. 3 times x times 16 is 48x. And lastly, 4 cubed is 64. Okay. So we just cubed that much faster than we would have had we had to write that out. Okay. Let's do another one. This time with a minus sign, we'll do x minus 2 cubed. So we'll start with the first thing cubed. So I might even use some parentheses there. Plus 3, or no, not plus. Ooh, start over. Similar, get it together. X cubed minus, right, because we have a minus sign here now. 3, and it's going to be x squared times 2. Then we have plus 3 times x times 2 squared minus 2 cubed. Okay. So take a moment to see where all of those things come from. Remember, instead of a and b, I have x and 2. So this is x cubed, 3x squared times 2, 3x times 2 squared, and then finally 2 cubed. So when we work that all out, we get x cubed minus, this is going to give me 6x squared. 2 squared is 4. So 3 times x times 4 is 12x. And 2 cubed we dealt with quite a bit recently, which is 8. So we end up with this as x minus 2 cubed. Okay, we have one more small topic to talk about. Let me see if I can get this flipped over. And that is, oh, I gotta scoot this. Yeah, we're good. Uh-oh. Did you guys see that at the bottom? I hope. Let me see. Sorry. Let's see. Yes, yeah, you could. Okay. Sorry. I want to make sure you didn't miss anything. All right, next we have polynomials in several variables. Here's an example. Sometimes we have polynomials and they don't just have x's or y's, but they have lots of variables like 7x squared y cubed, and we have a polynomial in x and y, minus 17x to the fourth y squared, plus xy, minus 6y squared, plus 9. Okay, so here is an example of a polynomial. Again, it's the sum or difference of, this one has 5 terms, 1, 2, 3, 4, 5, and all of the variables have whole number exponents on them. So we're good to go there. And let's talk about now that the degree of each term is the sum. What does sum mean? Add. So the sum of the exponents on all variables. So for our example of 7x squared y cubed, 17x to the fourth y squared, xy, 6y squared plus 9, okay, the degree of each term, okay, in this case, we have to add these exponents together. So the degree of this term of 7x squared y cubed is 5. The degree of this term, we add the exponents on the variables together. 4 plus 2 is 6. The degree of this term, again, we have exponents on those variables. 1 plus 1 is 2. This one only has a single variable, so it's just the exponent on that variable, which is also 2. And this one has no variables, so we have a degree of 0. So the degree of this polynomial is still the highest power, or the highest degree term. Okay, degree of the polynomial. Okay, so that part is not any different than what we talked about earlier. Maybe I need to write over here, degree of each term. Okay, so we've written the degree of each term. The highest one is now still the degree of the polynomial. Okay. All right, that will do it for our notes for this whole section. So you're going to have an assignment, which is, I'm going to write here, section P3, page 53 to 54. You're going to do 2 through 86 even. Okay, so you've got some time, I'm sure, once you got done with these videos, because they're in total going to be, what, 30 or 40 minutes. So you've got about half the hour that you can kind of get started on doing some of those. Let me just remind you again, as you're working those special product problems, make sure that you use the patterns. Don't write them out and foil them, okay? Work on trying to use the pattern so that you can start doing it much quicker. Because sometimes what is going to happen on tests is that they are going to be somewhat timed because you have to complete them in the class period. And if you have to spend too much time writing things out and multiplying them versus applying some sort of pattern, then you're going to have a hard time getting the test done. Okay? All right, good luck with the assignment. Make sure that you get that done, and I will see you next time with another video. Woo!